today's lab, we're going to be separating a mixture by the physical properties, and it's one of those labs where you're going to be asked to design it. The first page has a purpose. There's a couple of pre-lab questions it's going to be asking you to answer, and really read through the background information because those are going to be the type of procedure that we can use in order for us to be able to separate it. Since I'm going to be conducting this lab, a lot of the information I can fill in as I'm going through it. On the second page, we have our list of materials, and I'll show you all of them. The one thing with regards to the protocol for this is that it's really a mixture of set steps in the beginning, and then you're supposed to kind of have your own design and work through your own procedure. But with the restrictions that we have, I'll go through all of the pre-measurement and then give you a chance to plan what you think you would have done if you had the chance to do this lab. And then I'll go through what we think is the best approach to separating these mixtures. Now, on this third page, we have quite a few information that needs to be filled in. We have 5 objects that we're going to be mixing together. And one thing that you need to help using this video is I need you to record the particle size, and it's all relative, just based on the 5 things here. Is it small, medium, or large? The density, whether or not it floats in water, so we can do that test, so you could record it. Is it attracted to the magnet, and does it dissolve in water? So I'll do those tests real quick, so that way you can fill that in. In addition, I'm going to be helping out in the bottom portion here. I'll measure the mass of the Erlenmeyer flask, and I'll measure the mass of the filter paper. In addition, I'll measure the mass of the empty cups that we're going to be using, the mass of the cup with the substance added to it. But from that point on, letter C or column C would be your calculation. There's an error there. It should really say column B minus A. And you'll notice up here it says all of those are preparation. That will be the first part of this video. And then the second part of the video, you'll get the result for the separation. So let me step back and start showing you all of the materials to help. And at this point, this is where I'd like you to start recording your idea of the particle size. I'll also test out a bit of the density for it. So here's our salt. So you can kind of like describe its particle size based on your own understanding. I'm going to add a little bit into our water there. So kind of make a decision on whether or not, because you have to decide on whether or not it floats or not, or if it's soluble or insoluble. And this is just like a regular salt that we're using. The other thing we can do is test. This is a magnet, and does not look like it picked up anything. Now we have our second one. This is sand, so I'm going to pick up a small amount and dump it in our water. So there it is. Let's do a magnetic test. There's a little bit of specks in there of sand. Let me clean that up. All right, next one is we have our steel nuts. And for this one, I'll just do a quick test, and as you can see, stuck to it. Let me put it back. I will take one of the steel nuts and dump it in our water. So here it is. All right, next one. Let's do a test for, these are called pop beads. So touching that, nothing. Pick up one of them. It has a hole in it. It's made of plastic. So let me dump it there. Here's our pop beads. And our last one are pebbles. So let me touch the pebbles that we have here. Nothing. Pick up one of them. And you can talk about all the other properties that need to be filled in on that table. Set it down there, and there you go. So with that, with just that quick test, we can now fill in the particle size, the density, the magnetic property, whether or not it's attracted to that yellow magnet I was using, and does it look like it dissolves in water, either from what you've seen or based on your understanding of these objects. All right, the next part, we need to start measuring these things. So to help you out, I'm going to measure the mass of the empty cups, and then I will add each of the substance, the mass of the cup for each substance. So first, let me compile all of our cups together. Okay, so hold on to this. Here is, so it's zeroed. Salt, just the empty cup for our salt is 3.81. For our sand, 3.89. For steel nuts, it's 4.19. For pop beads, 3.87. For the pebbles, 3.83. We also need to record, let me make sure it's back to zero, our filter paper, 1.31. And so let me just move this slowly. The last one we got to record is our Erlenmeyer flask, and it weighs 119.81. Okay, so the next thing we're going to have to do is start measuring all of these substances. So we have our, let me put this in the correct order, sorry, pebbles, we have our pop beads, we have our steel nuts, sand, and salt, making sure that I have everything placed in the right spot. So I'm going to measure, and it's not, the idea again is since we're separating it, we're just kind of estimating about a teaspoon of it. So here's our sand, here's our steel nuts, here's our pop beads, and here's our pebbles. And for each one, I'm going to start measuring them. Let me move them closer first. Our scale, sorry, move all the moving around here. All right, let's start, let's keep this in order. So salt, it is, so this is the cup with the substance in it, 7.67. Our next one was sand, 7.76. Our next one, I'm sorry, this is supposed to be the last one. These are the pebbles. So 9.20. So again, this should be the last one on the list, pebbles, 9.20. Let me put them back in order again. These are our steel nuts, 16.07. And then our pop beads of 7.76. All right, so now I have all of the pre-measurement, and we're now at a point where we could mix all of this. So it's a pretty simple task. So let me just start dumping everything. Make sure I got most of that, especially the salt. Mix it well. All right, so here's what we have. Your task from here on is to design an experiment using the list of materials that's on your handout there. I can show you the visual of those list of materials. So what is available for us, we have filter paper, a plastic sifter, an aluminum pan, plastic container, a funnel, some water, a plastic spoon. We could light up our setup here with the Bunsen burner, and it's pretty limited resource, and we could even add like some beakers if necessary. But the goal is design an experiment that will separate these 5 materials.